Hi guys! Welcome sa ASIP9. In this video ay itutuloy natin yung series natin on calculus. Sa previous video, napag-usapan natin yung dalawang problems na nagresulta sa pagka-imbento ng calculus. Yun ay tinatawag natin na tangent problem tsaka area problem. So in this video, pag-uusapan natin in detail yung tangent problem. No? Kung napanood nyo na yung previous video, napag-usapan na natin na ang tangent problem ay problema ng mga mathematicians kung saan kinukuha nila yung slope ng line tangent to a function. For example, dito, meron tayong function na f, yung kulay blue, yung graph. Tapos meron tayong line L, no? Kulay green. And line L is tangent to the function at point P. No? So, the problem of mathematicians was, what's the slope of line L? Slope of line L, no? Which is the tangent line. Madali lang yung slope kung mayroon tayong dalawang points, no? Kasi if we have 2 points, x sub 1, y sub 1, tsaka x sub 2, y sub 2, makukuha natin yung slope which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, ang problema natin dito, isa lang yung given point, no? Yung P. So, wala tayong second point, kaya hindi natin pwedeng gamitin yung formula ng slope. So, paano ginawa ng mga mathematicians ng paraan para makuha nila yung slope ng P? Ang ginawa nila ay gumawa sila ng another point, no? For example, Q, at gumawa sila ng line passing through Q and passing through P. Hindi siya straight, no? Pero I think you get the idea. So, yung line na to, ang tawag natin dyan, no, from your geometry ay secant line. Now, the idea of mathematicians is to move Q, no, to move Q towards P para ma-approximate yung slope ng tangent line. No? Now, ito yung sinasabi ko, no, yung mga mathematicians, gumawa sila ng another point doon sa function. Ang pinangalanan nila yon, for example, Q. And gumawa sila ng line passing through P and through Q. Yun yung secant line, tinatawag natin. Ngayon, para ma-approximate yung slope ng tangent, no, gagawin nila is ilalapit nila yung Q doon sa P. And makikita nyo numerically, no? Makikita nyo numerically dito na palapit ng palapit yung slope, no? Of course, it can be any slope, no? Kung makikita natin, Q approaches P from the right. No? Okay? Paano kayo kung from the left? Kung nandito yung Q sa left. So, negative yung slope niya, no? Pag inusod natin papunta sa right, ano nangyayari doon sa slope? Ganun din, palapit din siya doon sa slope ng tangent line, no? Okay? So, yan yung idea ng mga mathematicians para ma-approximate yung slope ng tangent line. No? Okay, so buuin natin yung idea. So, as point Q approaches point P from the right, the slope of the secant line approaches the slope of the tangent line. So, ito yung sinasabi niya, no? As Q approaches P from the right, the slope of the secant line approaches the slope of the tangent line. Makita natin yan dito numerically, no? And of course, no, kahit walang numbers yan, pag pumatong na yung red line dun sa green line, magiging pareho na sila ng slope, no? Kasi magiging the same line sila. Okay, now next idea. Now, as Q approaches point P from the left, the slope of the secant line approaches the slope of the tangent line. Napakita naman natin yan kanina, no? Okay, ito yun, no? Pag galing naman sa left yung Q, ganun din naman. Palapit din naman yung slope ng secant line doon sa slope ng tangent line. So, we want to make point Q as close to point P as possible, but not coincide with point P, no? Gusto natin malapit na malapit, no? Pero, hindi rin naman siya papatong dun sa point P kasi babalik siya dun sa original problem. Pag pinatong mo yung dalawang points, magiging isang point lang siya. So, yung idea na yan na palapit yung Q sa P pero hindi papatong, yan yung tinatawag natin na limit, no? So the limit of the slope of the secant line as Q approaches P from the left and from the right is equal to the slope of the tangent line. So yung word na limit, palagi nyo yan maririnig sa calculus, no? And in fact, yan yung foundation na nagko-connect sa integral at sa differential calculus. Now, don't worry kung hindi nyo pa naintindihan ngayon, kung hindi nyo masyado naintindihan ito. But as we go on, no, we will have more examples. And makikita nyo kung bakit nako-connect ng limit yung differential calculus tsaka integral calculus. Alright, sa susunod na video, pag-aaralan natin yung area problem, yung pangalawang problem na naging dahilan kung bakit na-imbento yung calculus, no? So itong tangent problem na ito yung differential calculus. At yung susunod natin na aaralin ay yung integral calculus. Now, before tayo mag-end, take note of the word limit kasi mamimit nyo rin yan sa susunod na video. Alright, maraming salamat. I'll see you in the next video.